make sure there's no questions. After that, we're going to be working on expanded notation. Okay, so those are the two that we're going to start with to begin with.
What are we starting with?
I want you to pull out your the basic packet. Hopefully you guys had a chance to go over those, make sure there's no question. Because if you don't know the basics, guys, it's going to be hard. It's going to be very, very hard.
It says basic packet on it.
It should say, here, hold on a second. I will show you what it looks like. Oop. Miss Kate.
I already started.
Disable my screen sharing.
Oh, sorry.
Now I'm on a multiplication, but I already started.
Started those? Okay.
Oh, wait, security.
I'm done with my packet.
All right. Glad to hear it. And as long as there's no questions, guys.
It should work now.
Thank you. It does.
Mr.
Okay.
Jim.
The basics one looked like this. Wow, somebody sounds angry. Okay, so let's see, 1, 2, 3, 4. We're still missing a couple people, but you know what, ladies and gentlemen, your time is too important, and we've got a lot to do.
I don't even have one that look like that.
You don't have something that looks like that? Oh, jeez. You would have gotten it probably about almost 2 weeks ago now.
No, I know that. I got all of these, so I mean.
Okay. All right. So, so what it was, I'll go over them really quickly to show you, and then if you have any questions.
Mr. Jim,
I hear you.
I sent you a message.
You did? What, text or?
Over the Zoom thing.
Over the Zoom thing, okay. Let me.
I didn't want to talk in front of everybody, but it's like what we talked about with Miss Sam last week and Miss Kate.
Okay. Yes, I understand
So
that.
we get a chance.
So what we're going to do, I just want to make sure that when was the last time you were in school?
I'm done with school.
Okay, so you've already gotten your high school diploma. So we'll continue on with that. But for right now, I want to make sure that everybody's okay on basics. So it would probably be something good for you to hang on into. All right? All right. So let's get started. Math basics. So ladies and gentlemen, if you have the packet, it's just, we started out with just simple addition. Did anybody notice anything about these packets? Don't tell Mariah. This way I know if you actually did them or not. What about these packets? Like the back of this page?
Can I just say it?
It's supposed to be
Go
entry.
ahead. I will not give you a worksheet unless I give you the answers to go with it. So the front of it is the questions. And if you look at the back of it, it's going to be the answers. Because everybody works at a different pace. Some of you need to do more work on something if you aren't sure on it. Others of you are okay with it. So if you can go through and do them, that's awesome for you. Okay.
I was doing it, and I didn't notice that there was the answers on the back. I was just doing it, and I was off the page to go try to do the next page. And I'm like, why is the same thing on the other page?
Hopefully you got the answers on the other page. So,
I did.
So you made sure that they were right.
I didn't know there was answers on the back. Like I just kept doing it. Then I flipped the page thinking it was more questions, and I seen like, oh, it was the answer.
Yes, that was my kind of. Let's see if they're paying attention here. So again, we did addition. Hopefully nobody had any problems with that. We did subtraction. And remember, one of the big things is having to borrow. If you look at this sheet, can everybody see this, my packet? Hopefully. Okay. For like this question right here, remember that you have to borrow. Okay. Or excuse me, no, you don't have to borrow. Where's the one that we have to borrow? Ah, here we are. Forget this. Let's change that. And this one right here, we're going to have to borrow because you cannot subtract 8 from 5. So remember, you have to borrow. So this becomes 5. And this becomes 15. This is going to become really huge when we start working on some of the other things. Okay, so 15 minus 8 is 7. And then 5 minus 3 is 2. Okay, again, this is for people that, you know, may not have been in school for a while or whatever. Just get to thinking again about it. So does anybody have any questions on this?
Yeah, I didn't even borrow. I just did the answer.
Okay, did you know what it, you could figure out what the answer was though? You used logic, right?
Huh?
You used logic to figure it out?
Yeah, I didn't borrow. I don't know. I didn't know we were supposed to do that. I was thinking at first like we were supposed to borrow, but I was like, I'm not doing all that. So I was just sitting there and just looking at it, and then I wrote the answer down.
Okay.
Mind
All right,
you,
did you
not
get it
knowing
right?
the back of the page, but I just still did not like think about that.
Okay. All right, it's just something to keep in the back of your mind. Math is actually logical, guys, believe it or not. Do you need to do the full process that they taught you in elementary school? You have to do A, B, C, D in a certain order? No. If you can get to D just by looking at the problem, awesome. You're using your brain. You're adults. Okay? You're going to be instinctively, you're going to know how to do some of these things. So that's awesome that you did that. It truly is. I want you to use your brains. Okay? Think outside the box. That's one of my big things. If you can do something differently, there's, I think, 8 of us on this call. There's probably 8 different ways of solving every problem. As long as you get the right answer, that's the main thing. Okay. So that was subtraction. Multiplication times table. Ladies and gentlemen, if you have not memorized your multiplication table, it's going to be much harder for you as we go down the road. Okay, just some, let's see here. You know, if you can work on these, just to refresh it in your mind. Okay, I did also put the answers here on the other side. And notice, math is always going to be in patterns. All right, so it's going to make it so that if you can break things into smaller pieces and find the pattern, you're going to be successful. I don't care what it is. Eventually, we're going to get to figuring out quadratic equations. But that, again, is recognizing the pattern. And we're going to get there. We really are. Okay, it's going to be a lot of work, but we are going to get there. So we have multiplication. Anybody have anything that they'd like me to go over with them on this, or you're okay? Okay, I'll take that as a probably we're okay. You're going to have to unmute yourself, guys. I cannot see my chat button. All right, so multiplication, we figured that out. Divisibility rules. All right, if you can check those, you know that a number is divisible by 2 if it's even. Okay, I'm sorry, my furnace is in the background here. I like having hot water, so it comes on occasionally. So if you can't hear me, let me know. Divisibility rules. So if it ends, last digit of any number is a 0, 2, 4, 6, or 8, you know it's going to be divisible by 2. If you add up the digits, say like you had 42. If you add the 4 and the 2 together, that's 6. 6 is divisible by 3, so 42 is divisible by 3. Okay. For 4, they say if I like This one probably the most. If the last two digits are divisible by 4, then the whole number is divisible by 4. For 5, that's pretty easy. It's either 0 or 5. If the number ends in 0 or 5, you know it's divisible by 5. 6, it has to be divisible by 2, this rule up here, and 3, and then you know it's divisible by 6. 8, there is nothing for 7. 8 is kind of ridiculous. Yeah, use your calculator. And 9, is the sum of the digits is divisible by 9, then that number is divisible by 9. Okay? So those are things that you're going to have to try to keep aware of and use them when you can. All right? So like for this first one, we know this is going to be even. We know that 5 will go into this evenly because it ends in 5. All right? For this one, we have to follow the rules of 2 and 3. Okay? Is it divisible by 2? Yes, it is because it's even. Is it divisible by 3? Well, I'm going to add 3 plus 8 is 11. 11 plus 7 is 18. 18 plus 6 is 24. Is 24 divisible by 3? I'm not 100% sure, so I'm going to add 2 and 4 together. And 2 to 4 is 6, and 6 is definitely divisible by 3. So that means this will be even. Okay, it will go into it evenly. All right. Again, did anybody have problems on these? Okay, please make sure you ask because it's easy to help make things simpler. I'm what's called a very lazy mathematician, so I'm going to find the easiest, safest way to do things. I'm not going to try to complicate it and make it like you have to follow some huge pattern in order to solve a problem. It's not. Math is really a lot easier than most people give it credit for. Okay? So if you have questions, ask. Okay? Here was your answer. Remember, for this, they asked you to leave it in a remainder. Okay? We'll be working on changing those into fractions eventually. This is just some more practice because it seems like division is the worst problem for everybody. Most people have problems with this, division, and also fractions. So we're going to try to get those two out of the way first. Okay? Nancy, I can see you talking. I don't know if you're talking to me or not. Okay? So if you do, okay, that's fine. And again, this is double digit. Ladies and gentlemen, to solve this double digit, what you're going to do is what we call a guess and check. So for this first one, you're going to round it off to 100. How many times will 100 go into 3? It won't go into 37. We'll go into 2 or 372. It'll go about 3 times. Okay, so you put a 3 up there, then go back and do the actual work. 3 times 98 would be 296, if I remember, 94. That's not right. Okay, I'm doing it in my head. So, so again, guess and check. All right, and that's how you're going to find the solution on those. All right, we're going to work a lot more on some of this type of thing because I was talking to your culinary instructor, and he says it's really important that you have these basics down. Okay, and we're gonna do our best to get you there for that. Okay, so again, guys, if you have any questions, please ask. Text me, email me, whatever you want. Unmute yourself so that you can ask the question. The only bad question is one you don't ask. And again, any worksheet I give you, unless I really screwed up, will have the answers on the back so that you can proceed on that at your own pace. All right, you aren't waiting for me to say, yes, that's right, or no, that's wrong. Okay, sometimes if you see it's wrong, you'll be able to figure out the mistake before anybody else will. Okay? All right, so that is math basics. And if there's no questions, I want to move on. Okay, so let me cross this off that we've got here. Questions on basics. Got it done. All right, expanded notation. So you should have this packet that looks like this. It's a short packet. I think it's only 2 pages or 4 pages total. Or excuse me, 2 pages total on expanded notation. All right, so we're going to be using, it's really going to help us to understand place values and the names of those values. All right, so if you look at this table right here, again, I'm not going to have you worry about this portion at this point. I just want you to remember here, we're going to start the ones place. Everybody knows what that is. All right, ones, tens, hundreds. That's called the ones period. Then we have 1,000, 10,000, 100,000. That's the thousand period. Okay, millions. Here's where we're talking about your paychecks. Okay, millions, 10 millions, 100 millions. Okay, that's the millions period. The period means it has a 1, 10, and 100. Okay, then we're up to billions, and I'd love to see you think how to get there. Okay, so what we're going to do is we're going to take 345, and we're going to break it down so that we're going to use expanded notation. So 345, this, I'm sorry, what? Everybody okay? Now, you look like you're still looking for it. It looks like this on the front. Okay. So we've got 345. So this 3 is in the hundreds place. So in expanded notation, that would be the same thing as 3 times 100. Then we're going to add together. All right. Our 4, this is in the tens place. So that would be 4 times 10. Okay. And this, let's get another color here. Okay. The 5 is in the ones place. So you would have 345. All right. So 3 times 100 plus 4 times 10 plus 5 times 1 is expanded notation for that. Okay. If we were going the other way, 4 times 1,000, well, that's in the 4,000s place. Let me change this color so it's a little easier to see. So that would be 4,000. 3 times 100. Please always make sure you put commas in between the periods. All right, so 3 times 100, 2 times 10, and 1 times 1. So ones place, tens place, hundreds place, thousands place. Okay, so that would be your answer right there. Okay, so this is the expanded notation worksheet. Ladies and gentlemen, I'm not going to, and that's one of the things that we're going to do as far as in math class. If you got it, I'm not going to ask you to do the whole thing. What I want you to do is I want you to do, like, if there's 10 problems here, if you do the first 5 and you got it, don't bother doing the second 5. If you understand it, you don't need to do them all unless you want extra practice. Okay, so we've got 800,000, all right, 4 times 10,000, 8 times 1,000, 4 times 100, 8 times 10, and 8 times 1. So in expanded notation, it would look like this. Okay? Not really all that hard to do, I don't think. All right? Realize one is in place, the set, and this one is in the ones place. That's what we're trying to get you to recognize is place values. It's funny how people just sometimes don't realize it. And if you make a mistake with your place values, it could mean that you aren't going to be paid the right amount. Okay, for down here, let me make this a little bigger so it's a little easier to see. Okay, so here, let's move down here so it'll be a little simpler. Number 15. All right, so we've got 5 times 10, so that's in the tens place, and 7 times 1, that's the ones place. So there is your solution to number 15. It's just asking you to put things in the right spot. If you look up here on number 11, notice it's 0 times something. Remember that zeros are just placeholders. That means there's going to be a 0 in the 10,000 spot. All right. Down here for 12, there's going to be a 0 in the 100 spot. Okay. So ladies and gentlemen, try a couple. See if you can do it. If you can, awesome. If you can't, ask questions. Okay. All right. Coffee break, sorry. So I'd like you to just take, let's say, about 3 minutes and just try a couple of these. And then we're going to move on. We'll be done with expanded notation.
Can I say the answers or?
Can you say the answers? Well, let's
Yeah.
give everybody a chance first.
Okay.
Okay? But absolutely. I like it. Somebody. All right, Bree, if you want to give us like the first 3 answers for like answers for 1, 2, and 3, and then 11, 12, and 13, that would be awesome.
Hello.
You there, Bree?
My Wi-Fi is frozen.
Oh. Okay.
Hello.
Hi, I hear you. Can you hear me?
Yes, we can hear you.
Okay. All right. Bree's was her Wi-Fi was frozen. All right, guys. I don't know if Bree's going to be able to get back or not. Can anybody give me the first, like questions 1, 2, and 3? What would the answers be?
I'll do it.
Okay. Thanks, Brian.
This first one is 8 times 100,000, 4 times 10,000, 8 times 1,000, 4 times 100, 8 times 10, 8 times 1, The second one is 1 times 100, 7 times 10, and 1 times 1. The third one is 2 times 1,000, 5 times 100, 5 times 10, 5 times 1. The bottom number, number 11, the bottom should look like 7, comma 808, comma 215. Number 12 should look 6, comma 204, comma 084. 13, 4, comma 981, comma 391.
Okay, excellent. Thank you. Everybody okay with that? Can we move on?
Yes.
Sorry you're having issues with your Wi-Fi. Maybe if you sign off and come back again, it might work better. I'm not sure.
Can you hear me?
I can hear you now.
Okay, yeah, I can see you guys now. I just couldn't hear you guys for a minute.
Okay.
Yeah,
Nice.
my Wi-Fi did go out.
I could barely hear you guys.
Okay. Are you okay on these three? I just had Mariah. She just answered the first three on both sections.
Yeah, that's fine.
Okay. All right. So, ladies and gentlemen, again, answers. I'll have them there because, again, some of you are much faster than others, and I don't want to hold you up. That's huge. Okay, so this was a short packet. Everybody okay with this? Is there any questions? Brilliant observations. Can probably help Miss Sam anytime she needs expanded notation.
Poof.
Yes.
She needs help on it.
Oh, wait till we get some more stuff here.
I was mad pissed off about it at first, but now I just like, I get it now. Now that I'm looking at it.
Oh, awesome.
Because at first I'm like, what am I supposed to do? Because I did all the write each number in standard form.
Mm-hmm.
I'm sitting there writing it in standard form. I'm looked up right in expanded form or notation, whatever you said. And I'm looking like, how am I supposed to do that? But I'm like, I just did it in standard form, so I should know how to do it in expanded notation.
Okay. Everybody take a look at Snazzy, will you? There's a light above his head. The light bulb came on. He got it. I love it. Okay. That's one of my favorite things is when the light bulb comes on. You got it for me. You're the man. Okay. All right. So, ladies and gentlemen, let's move on. All right. Again, we've got so many things to do and so very little time to do it in. So I'm going to depend on you to tell me if you understand it or not. Otherwise, I'm going to keep moving. All right. So, ladies and gentlemen, we're getting ready for your favorite things, fractions. Okay. I was talking to your culinary instructor, and he says, you guys are so good at fractions already. Maybe I can just go over them a little bit. Okay. We'll give it a shot. So if you would, please, pull out the packet that looks like this. The greatest common factor. Okay. All right. So, ladies and gentlemen, greatest common factor. Greatest is always going to mean the largest. Okay. Okay. So, first thing we need to do is what's a factor? Okay. And you have to remember.
I'm paying attention. I'm just changing this little boy.
Okay. What are you going to change him into?
Yeah, that's a factor. A factor is what a number could be. What number has what's the name in common? Like numbers in common?
Yeah, if we're talking pairs of them. But right now we're talking factors. And that's what the two numbers that can be multiplied to give you another number. All right? It's every whole number is the product of two or more numbers. So 2 times 3 is 6. 2 and 3 are factors of 6. That means you could break it down. 6 divided by 3 is going to be 2. Okay, so we can go by anything like that. So again, the proper definition is a factor is a number that is multiplied by another number to give a product or total. All right, like we said, 2 and 3 are factors of 6. 5 and 4 are two factors of 20. There's other factors of 20 too, like 2 and 10, 1 and 20 are all factors of 20 also. All right, so let's start taking some of these and try to find some common factors. So ladies and gentlemen, we're on slide 3. So that should be, if I remember correctly, the inside of your front cover. Okay. I probably already have these listed out for you. So 24, we're finding all the factors of 24. So 24 equals 1 times 24. Remember how I said, if you organize math, it's easier. Okay. So what I did is, all right, 1 times 24, 24.
6.
2 times 12 is 24. 3 times 8 is 24. 4
4
times
times
6, okay, is 24. So notice how I try to keep a pattern, and that's really a big thing about math, is finding the pattern. All right, so all right, 4 times 6 is 24. Guess what? 6 times 4 is 24.
8 times 3. Oh, right, that's that.
Yep. 12 times 2 is 24. 24 times 1 is 24. Now we're going to look for the factors of 72. 1 times 72, of course, is 72. 2 times 36 is 72. 3 times 24 is 72. 4 times 18. Again, if you aren't sure, just go into pattern. Remember how we talked about rules of divisibility? This will help you. 6 times 12 is 72. 8 times 9. And 72 equals 9 times 8. So those are all the different factors of those two numbers. So what we need to do now, and the rule, or what we're striving to do, oh, wait a minute, let me back up here. Remember, commutative property, multiplication. If you think about it, if you commute from your home to your office or to wherever you might work, is the same distance from your office to home. Like you're commuting, all right? So order does not matter. That's what commutative means. It's the same whichever order you do. Like 3 times 4 is the same as 4 times 3. All right? That's commutative property. All right, so getting back, greatest common factor is the largest common factor shared by 2 or more numbers. So here's my 24 and 72. I want to find the greatest common factor of that. So here I'm listing all of the factors that I figured out of 24 are right here. All the factors of 72 are right here. So I need to find the biggest number that will go into both.
24.
And if you look at it, the biggest number that's in both is 24. So the greatest common factor of 24 and 72 is 24. Let's see if I can. I'm really practicing my handwriting, guys. I'm not, or mouse writing, I should say, not handwriting. My handwriting stinks anyway, right, Mariah? Okay. So now if we were looking for 36 and 54, we could list all of the factors, all right? 1 times 36, 2 times 18, 3 times 12. I missed 12 here. 2 times 18, all right? Those are all factors of 36. Here's factors of 54. All right, so now what I need to do is I need to find, oh shoot, okay. I got to change this here a little bit, guys. Okay, there's an 18 in there, which is a factor of 54. So my greatest common factor is 18. 18 will go into 36, and 18 will go into 54. Those are common factors. Make sense? Did I screw anybody up yet? Okay, my day won't be complete unless I do, so let me know, all right? All right, so ladies and gentlemen, take a look at this. We're on page 7. It should look something like this, and I want to show you some cheater things that I like doing. Let me make this a little bigger so people can see it. Okay, so I'm finding the greatest common factor. Come on, get over here. Of 20 and 2. Well, naturally, you know that the biggest number that'll go into 2 is 2, right? Well, and if 2 will go into 2, then 2 will go into 20, right? So our greatest common factor here has got to be, whoops, has got to be 2. All right, ladies and gentlemen, what I'd like you to do and what I'd like you to start thinking about is when you're doing 2 numbers, what I want you to do is I want you to take the smallest and see if it'll go evenly into the largest one. Okay? 2 will go into 20, therefore 2 is the greatest common factor. Let's do the same thing. This way we don't have to list out all of the factors of these. These are just some, I call them Gardner cheaters, okay? Things for you to be aware of. Will 8 go into 24? Yeah, it will, 3 times. So that means for here, 8 is your greatest common factor. Okay, here we could, I'm sorry?
Oh, sorry, I was saying the answers out loud.
Oh, okay. Okay.
Good, I
Well,
was muted.
no, that's no problem. All right, so again, if we use our cheater method, we know that 15 would be. Okay? If we didn't, then we'd have to list the factors. 30 would be 1 times 30 or 2 times 15 or 3 times 10. But if I see this 15, I don't have to do any more work. So, ladies and gentlemen, be lazy, would you please? Do it as simply as you possibly can. All right. Okay. 10 and 4. Will 4 go into 10? I'm going to say probably not. Not evenly, anyway. All right. So let's break down 4. 4 would be the same thing as 2 times 2, correct? Well, will 2 go into 10? Yeah, it will. So the biggest number that'll go into both of these is 2. Okay. Number 5, 12 and 24. Well, 12 will go into 24. Okay. It'll go into it twice. So 2 times 12 is 24. So those are factors. 15 and 40. Well, 15 won't go into 40, will it? So what's the biggest number that'll go into 15 that will also go into 40? Well, 15 is the same thing as 3 times 5, right?
Oh, so it's 5. Okay.
Okay. So if
You were right.
okay, so if 15 goes or 5 goes into 15, will 5 go into 40?
Yes.
Yes. Thank you. I do make voices when I teach. My grandkids love it. So I pity you. Sorry. Okay. So, ladies and gentlemen, these aren't hard as long as you know your multiplication table. That's why it's really kind of important for you to understand those.
Will 4 go into 12? Yes.
Yes, it will.
3 times.
Yes. So our greatest common factor, 4. So for number 8, come on, Bree, teach us.
Number 8, 6.
Guys, I get paid by the hour, so if you guys teach it, just make my life easier. So teach each other. What are we gonna do? 12 and 30.
It goes in 6 times.
What goes in 6 times? No, you're right with a 6, but just explain why, so that everybody else can understand why. I think what you're saying is 6 will go into 12 and 6 will go into 30.
Yeah, 6 goes into both numbers.
Yes. And that's the biggest number. Okay.
That they have in common. It's 6.
The next one is 6 because it goes into both numbers. 6 goes into 6 one time.
Uh-huh.
Baby, ain't nothing old about Bree Bree.
You doing okay there, Bree?
Oh yeah, I'm sorry. I'm hyped because I know these answers.
Awesome. Awesome.
Come
If you
on.
guys would ever like to teach a class, please let me know. I'd love to, because you know what? I know I look like I'm a teenager still, but I'm not. Stop laughing, Miss Sam. So I don't speak young person, okay? I'm medieval. I don't know if you know what medieval is. Okay, it means I'm from a long time ago. So you speak young people, I don't. So if I make a joke that you don't get, it's probably because I'm so old. I can explain it to you, or you can just say, well, that's move on. Okay, I'm sorry. So that's the end of my story on that one. So number 10, what do you got? Who can figure it out?
The Arcanite Trail leads to Miyagami Island. Lower the
2.
Who says 2?
Bria.
Bria says 2?
into the transport control system.
It's not 4?
Oh wait, 2 is the lowest number. The greatest number is 4.
No, it's not.
It's 2. 2 is the greatest number.
2 is the greatest common factor.
Wait, because 4 could go into 30.
28.
Oh no, it's not. No, it can't. I know 2 can. Wait, 3, 6,
No,
9.
I did the same thing, bro.
2733 can.
3 can.
3? 3 will go into
but
8?
3 can go into 8.
Yeah, 3 can't go into 8.
Yeah, you're not looking at the problem. I'm looking at the problem.
Oh yeah, I'm just hearing you say yeah. What's the question?
Number 10, we're looking for the greatest common factor of 8 and 30.
Yeah.
Yeah. 8 and 30 is 2, yes, because it's even. He's right there. If 8 wasn't there, 3 could go into 30.
All right, Kadeem.
Okay.
It's not our class.
My fault, I'm sorry. I just heard the question and I'm right here.
Yeah, no, guys, please, jump in. Teach me.
I got you. I'm here.
You're there. All right. Glad to hear it. So the agreement is 2. I got you.
I got it.
I got you. Okay. All right. So let's see. Do you guys want to do any more of these, or
You need to be on here with them.
No.
You know why?
who was given the information there? I love kibitzers. It's fun.
You said what?
I love people that kibitz.
I do. The hood. GD.
Yeah, we about to get on the laptop and join.
The more the merrier is the way I feel about it. Okay, so guys, is there problems on this? Are you okay?
Yeah, I'm good.
You okay with that? Okay.
Yeah.
I do want to show you a different way because sometimes it's not going to be quite so simple as this.
You know how I think about it?
How?
You know the notebooks when you used to, well, when I was in elementary school, the notebooks used to have the multiplication table on the
Yep.
back of it, and I believe 30 was like the highest number.
Yeah.
I'm like, oh wow, look at all these numbers that go into the same number when I used to learn it. So
Yep.
that's how I think about it now. Still.
Absolutely. In fact, guys, for when we did, let's see, the last packet, there was a multiplication chart there. If you're not 100% sure on your multiplication chart, pull that out. I don't know if you keep it in a note, your things in a notebook or a file or just a big pile. Put that multiplication chart on top. I agree 100%. Use the tools that you're given. If you're trying to dig a hole, would you rather use a teaspoon or would you rather use a shovel?
A teaspoon.
Really? You would? Huh. Okay. Not me. I'd like to do it a little bit easier than that. So I'd like to use the biggest, best tool that I can. So if you have a multiplication chart, you want to use it, great. But eventually you're going to need to know those multiplication tables. Okay?
I'm about to log off and log on my laptop.
Okay. See ya.
Be back.
Okay. All right. So ladies and gentlemen, are we okay on this? Unless
Yes.
we're okay? All right. Now, another option is if we use prime factorization. Ladies and gentlemen, some of my students love this, and other students say, why the heck did he ever teach us this? Because it just doesn't work for me. Okay, there's lots of different people, a lot of different things that work for different people. Okay, so if we use prime factorization, so again, I need to just remind you what a prime number is. So if you look at page 10, okay, it says, remember that prime numbers are numbers that can only be divided by 1 in itself. So prime numbers, you don't need to know them all, but you need to know some of the basics. You need to know that 2, 3, 5, 7, 11, and 13 are all prime numbers, meaning they can only be divided by 1 in itself. Those are the only two factors. All right, so let's go back here, and we're going to use what's called prime factor trees, or factor trees. Remember how we were saying that for like 150, all right, we broke it down and we said 150 is the same thing as 10 times 15. Those are factors. Okay, well, let's break the 10 down into a smaller piece because it's not prime yet. All right, so 10 is the same thing as 5 times 2. Well, once you memorize those prime factors, then you know that those are prime numbers. Ooh, I like that. Okay, and 15 is 3 times 5. Okay, whoever's got the feedback, oh, okay, thank you. It confuses me. I confuse easily. I'm old. So those are all the prime factors of 150. 225, well, it ends in a 5, guys, so I know that this 225 is divisible by 5. So I'm going to say 225 divided by 5 is 45. 45 is not prime because it ends in a 5, so I know it's divisible by 5. All right, so 5 times 9 is 45. And again, my 9's not prime. So that is the same thing as 3 times 3. All right, I don't know how many of you play poker or, I don't know, Noah's Ark, whatever. What we're looking for is pairs. Okay, so we're looking for pairs that are in both. All right, so we've got a 5 there and a 5 there. That's one pair. We've got a 3 here and a 3 here. That's another pair. and then we've got another 5 times 5, or 5 and 5. That's my third pair. So what I want to do is I'm going to say, all right, I'm going to take those prime numbers, okay, and just multiply them together. So 5 times 3 is 15. 15 times 5 is 75. Ladies and gentlemen, that is your greatest common factor. Okay, so that's using factor trees.
So the two first numbers are being multiplied. So we got 5 times 3, which gives you 15. 2 times 5, it gives you 10.
Yes, okay, now I got you. Yep. So I think what you're saying is this, all I did was I broke this into 2 separate parts, and I found the prime numbers that'll go into 10.
I didn't even do that. I just looked at 5 and 3 and then seen 10, and then 2 and 5, 15, they put it together.
Okay. You know what? I'm pleased that you looked at it and you used your head that way. That is awesome. There's no reason in the world why you have to do it all this way. It's just another option. Okay. Remember I said prime numbers are that. All right. So if we were looking for greatest common factors of 36 and 81, you could try to figure it out. Or you could say, well, again, I'm going to use a prime number to figure this out. All right. So 36 divided by 2, because that's my smallest prime. So that would be 2 times 18 is 36. I'm done with this prime number. All right. But I still have to split up this 18. So 18, again, I'm going to use my smallest prime number, is 2 times 9. Okay. I know 9's not a prime number either. That's the same thing as 3 times 3. So 36 is the same thing as 2 times 2 times 3 times 3. Okay. Hunky dory. All right, 81. Okay. 81. Well, 8 plus 1 is 9. That tells me that 81 is divisible by 3. Okay. So 81 divided by 3, because I'm using different operations, opposite operations, is 27. So 3 times 27 is 81. This is prime. Can't do anything more with that. But 27 is not. All right. 2 plus 7 is 9. 9 is divisible by 3. So I know that this is
9 times 3 is 27.
See, I
What are you
agree.
talking about? I'm right.
Oh man, I hate it when she's right. Okay. All right. So there we go, ladies and gentlemen. Are you familiar with Venn diagrams? Okay. A Venn diagram is just what do you have in common and what do you not have in common. All right. So if I look at this, I don't have any 2's over here, but I do have 2 3's. So I've got a 3 here, and I've got a 3 here. I've got another 3 here, and another 3 here. Okay. And everything else does not match up. So what I'm going to do is I'm just going to take this 3 times 3 is 9. And that is what your greatest common factor is. If you're going to use a Venn diagram, and just to getting you used to that, because you may see Venn diagrams on, you use that for ELA, and you also use that for science, you know, likes or when you're comparing things. Okay, so I had 2 times 2, all right, which is not over here. And I have 3 times 3, which is basically not over here, but I do have common 3 times 3. So, okay, so my 9, 3 times 3, 9, and that tells me what my greatest common factor is. And that's using prime factorization. If you break it down and you realize, oh, I don't have to keep going down. Can you simplify that? Absolutely. You don't have to go through all of the work all the time, just until you can recognize where you are. All right, greatest common factor of 18 and 108. Guys, I know I'm doing repetition, but it's to get that embedded in your brain. Okay, 18,
9 and 2, 18 and 1.
9 and 2, and 18 and 1. I'm got the 1 is not, believe it or not, 1 is not a prime number.
Okay.
Okay, so 2 will go into 18 9 times.
And
All
3
right.
and 3.
3 and 3. Okay, so here's all my numbers, my prime factorization. So now I'm going to go to 108. Okay, it ends in an even number, so that's 2 times 54. 54 is not prime, so that'd be 2 times 27. And that would be 3 times 9.
3 and then 3 times.
And 3 and 3. Okay, so now I'm going to just start circling here. Let's see, there's a 3 or 2 there. There's a 2 there. There's a 3 here. And a 3 here. Another 3 here. And another 3 here. And I've used them up. Okay, so 2 times 3 is 6. 6 times 3 is 18. That's my greatest common factor, ladies and gentlemen. Okay, let's say you were doing this, and all of a sudden you see, oh, wait a minute, I've got a 9 here. Oh, let me back up here. Let me use a different color. I've got a 9 here, and I've also got a 9 here. Oh, that just might work. So I don't have to go to this level down here. I look at this. Oh, 9. Okay, we'll go into 18. 9 will go into 108. That works. Okay? Greatest common factors. All right, so ladies and gentlemen, I want to let you work on these a little bit. Let's just do one of them together, and then if you've got it, great. If you don't and you need to do some more, absolutely. Okay. So what these circles are prime numbers. We're looking for the smallest prime number. So the smallest prime number here for 99 is going to be 3. Okay. So 3 times 33.
33.
Yep. So
And
now
then 11 times 3.
3 times 11, exactly. So that means the prime factors are 3 times 3 times 11 is 99. Those are all prime factors. Okay? Is everybody okay on these? Do you need me to go over any more, or are you...
No.
No? Okay. Thank you for being honest with me on that, Anson. All right, so again, check your answers, please. If you go through and do some more of these, and I'm going to highly recommend that you do, please use your answer sheet to check your work. Okay? You're right?
Yeah.
So, ladies and gentlemen, that means, guess what? We're done with greatest common factors. Okay, so I'm going to cross that off. Ladies and gentlemen, we have just done, in basically an hour, what would normally take in school about 3 weeks. Okay, that shows you how fast we're going to be moving, and it shows how important it needs to be for you to ask questions, because we cannot. I don't want to move on until you're sure of what you're doing. Okay. All right, so the greatest common factor is what number go into two other numbers. Least common multiple, that's where we're going next. So please pull out the packet that says least common multiple. Should look like this. Okay, so our vocabulary, ladies and gentlemen, and that's a big part of any of the task tests that you're going to be doing. Least means the smallest number. Common is a number that is shared for all terms. And multiple is the product of a quantity by an integer. So we're multiplying as opposed to dividing. All right, and I'll show you the difference for that. We are working towards fractions. Okay? So we want to find the smallest number that both 5 and 7 will go into evenly. And evenly is the big part. That is the critical portion. There's no remainders, evenly. So, all right, let's find 5. So we're going to multiply. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 is 20. 5 times 5 is 25. Yada, yada, yada. Okay. Then we're going to do the same thing with 7s. 1 times 7 is 7. 2 times 7 is 14. 3 times 7, 21. 4 times 7 is 28. 5 times 7, 35. That sounds familiar. So let's see. Are there any of these numbers that are over here? No. Looks like this is the only one that's common to both of these numbers, 5 and 7. Okay? So you can list them all out, and that will work. Okay, so our least common multiple, 35. Make sense? Hope so. All right. So if we try to find the least common multiple of these sets of numbers, you can sometimes look at these and figure it out. Who was it that was using logic? Was it Nichifun? I'm not sure. If we look at this and we say, okay, let's take these numbers and compare them. Well, I know 9 times 2 is 18, and 6 will go into 18, I know. So our least common multiple on this is 18. Another way you could do it, and that's what this is all about, 3 and 7, least common multiple. If you can't figure it out, then what I would like you to do is I'd like you to say, what's 3 times 7? Well, that happens to be
21.
21, exactly. Okay, so that's our least common multiple. Okay, 4 and 6. What's the least common? 12?
2.
2? No, we're looking for multiples, not factors.
You said what?
The least common multiple of 4 and 6. What number will 4 and 6 both go into? The smallest number that'll go into both.
12.
Okay. Somebody said 12, and somebody.
Bria said 12.
All right, Bree. You the person. Okay. So somebody said 2, and that is 2 is the least common, greatest common factor.
Najapon said.
Okay. So
I said 2.
who said 2?
Bria said 2 and 12.
Bria said 2 and 12.
Well, 2 is the greatest common factor, but we're looking for the least common multiple.
I got confused, but I knew what you meant.
All right, you the person.
I got the answer.
Yes. So the correct answer is 12. What number will 4 and 6 both go into? And that's 12. All right, 9 and 12, ladies and gentlemen. What is the least number that 9 and 12 will both go into? Well, we can start by saying, well, let's
24.
double. No. So if we double 12, we'll get 24.
9, 12, 24.
What's
wait,
12?
9 doesn't go into 24.
No, it does not. How about what's 3 times 12?
3. Wait, 8, 16, 24, 9, 18, 27. It's 27.
No, 12 won't go into 27.
Oh, no. I'm over here talking about my multiples. I'm talking
Oh,
about
okay. So you're just multiplying them out. Okay, we'll keep going
19,
a little bit.
20, 21, 22, 23, 24, 25, 26, 27. It's 9, 18, 27. So it's not 24. 12, 24,
Right.
36, 27, 36.
36? I agree, but I want to make sure I understand how you got there.
How I get 36?
Uh-huh.
Because 12, 24, 36, 9, 18, 27, 36 is the first number that 9 and 12 both have in common.
Wow.
Oh yeah, I know what she's talking about. I see it now.
Yeah, okay. Oh, cool.
Okay, Bria.
I ain't that old.
Okay, guys, I'm older than most of your grandparents, I think. All right. So again, here's some for you to try. Okay. Let me make it bigger again. I like being able to see it. Okay. What's the least common multiple for 4 and 8? Think it through. You don't have to do the work. Just what number will 4 and 8 both go into?
4, 8.
24. Oh,
16.
32.
I say 16.
I say no.
24.
No.
4,
32.
8, 12,
8.
16. 8 times 2 is 16. Oh, well, it's 8?
8.
8 is the correct answer.
Wow.
4 go into 4.
It says it
4
right
go into
there.
8. Yep. Well, 8
Well,
go into
8 could
8.
go into
Yep.
8 one time.
That's where people get tricked. Okay, sometimes they say, oh, well, I've got to go up higher. No, sometimes look at the numbers that are there. As an example, number 2, what's the least common multiple for 24 and 6?
24.
Was that, who was that?
Mariah.
Mariah, you're still there. Cool. I thought the kids ate you. Nice to hear from you. Yes, exactly, 24. All right, so if you look at number 3, let's take our biggest number and say, oh, well, will 12 go into 24?
2.
So 24 is the greatest or least common multiple. Same thing here for number 4. Here's 30. Will 15 go into 30?
Yeah.
So our least common multiple is 30. 8 and 30. Will 8 go into 30?
It's 120.
120? You sure? She's right, but how'd you do it? Did you peek at the back?
No, I usually multiply. I did this already, Mr. Jim.
Oh, okay. So you figured it out. How did you figure it out, though?
Because I multiply my numbers.
You multiplied your number. Okay. All right. So you said 30 times 2 is 60. 8 won't go into 60. 30 times 3 is 90. 8 won't go into 90. 30 times 4 is 120. Let's see, 120. Will that go in? 8 go into that evenly? Yeah.
Yes.
All right. 1. Remember, that's why we did division here, guys. 8 will go into 45 times. Oh, okay. No remainder. Okay? Questions on this, ladies and gentlemen? Okay, I know you're so excited about getting into fractions. And in order to do fractions, you have to be able to find, and to convert fractions, you have to be able to find either least common multiple or greatest common factors. That's why we're doing this first. Okay? So again, ladies and gentlemen, if you need some more practice on these, please go and do it. I'm not going to be checking your work on this. That's why I give you the answer sheet. And I don't give a lot of tests or things like that because there's really only one test that we need to be concerned about, and that's the task test. So do what you need to do to make yourself successful, okay? Now, believe it or not, there is another way of finding least common multiples, but I don't want to show it to you because I think it might be a little confusing. Or, well, tell you what, maybe let me just show it to you quickly. If you like it and want to use it, awesome. If you don't, throw it out. There's so many different ways of doing things that you decide what you like, okay? So I found the prime factors of 15 are 3 times 5. Okay. Prime factors of 25 are 5 times 5. So what I needed to do was find the prime factors, then I'm going to line them up. Okay? 3 I'm going to put in a column by itself. All right? I do have a pair of 5s, so I'm going to line up those 5s and then just bring it straight down. And then I don't have another 5 up here, so I'm going to put that by itself. So once I do that, I'm going to multiply all of these factors. All right, 3 times 5, or let's do it backwards because order doesn't matter when you multiply. 5 times 5 is 25, right? So you've got a quarter. How much do you have if you have 3 quarters? 75 cents. All right, so your least common multiple is 75. Did you have to do that 15, 30, 45, 60, 75, 25, 50, 75? Yeah, you didn't have to, but this is just another way to do it. Whichever way you like is the best way for you to do that. Okay? So again, we can try these, and we can say 6 is the same thing as 2 times 3, and 9, whoa, is the same thing as 3 times 3. So now let's do it down here. 2 times 3 times 3. Well, 2 times 3 is 6, times 3 is 18. So my least common multiple for that one is 18. Now the tricky part here is 3 and 7 are prime. If you have 2 prime numbers and you're looking for the least common multiple, there's a shortcut. What's 3 times 7?
21.
There you go.
Mr. Jim,
Yes?
did you get my first message?
What is that? Text or?
The one I wrote you on here.
Hold on a second. Let me.
Miss Kate, are you on?
I did not see it.
Okay. Well, I have to get ready. I have anger management at 12 o'clock.
Okay. Oh, that's right. You did tell us about that. Okay.
Okay, I did tell you. Okay.
Yeah, you reminded us of that not last time. Yes, thank you. Okay. So, Bree, what I'd like you to do, we're going to finish up this least common multiples. If you want to look at the packet for geometric figures, It's just some basic things, identifying they're all about. So just take a look at that. Okay, for next week. Okay? All right. Have a good time.
Thank you. Thank you.
All right, we'll see you later. Thanks.
Later. Later, guys.
Hasta la vista. Okay, so ladies and gentlemen, again, you can use logic, or you can use separating these into prime numbers, whatever works best for you. All right? Because the way I think is not the same way that you think. Okay? Any other questions? Here's another packet. If you want to try these, you can do that. But ladies and gentlemen, I'm going to assume you're okay on it. Remember that you can text me or email me, and I will be more than happy to respond to you. Okay? I can go on to, I have a classroom myself, that's a Zoom room that I can send you the link to if you need it. Okay? All right, ladies and gentlemen, believe it or not,
What we done?
we're done with week common multiples.
Where are we gonna go now? Where are we gonna go now?
Where are we gonna go? To hell in a handbasket. Oh, no, okay. Sorry, I'm sorry. You guys are underage. I shouldn't have said that. I apologize. Oh, well.
Underage. You can't hear you, little child.
I said underage. He's underage.
We're all
Right. I'm not underage. We're above age.
Again, guys, that's old people talk. So, again, if you got it, great. If you don't, okay. That's even better. All right, so ladies and gentlemen, the last packet we're going to work on is geometric figures. So we're moving out of fractions and moving on to geometry. We're going to be covering a lot of different topics in a lot of different areas. We're not going to do just one subject all the time. We've got algebra, geometry, numbers, we've got trigonometry, we've got all different kinds of things that we're going to be working on. So what I want to do is I want to jump around a little bit, because there's some people that hate fractions with a passion. Okay, so what I want to do is I want to give you guys a break on that too. So what my choice was today is greatest common factor, least common multiples, and then geometric figures. And a lot of this is just going to be vocabulary. All right, and that is so that you can understand. I don't know if any of you are ever going to try construction or things like that, and if you see blueprints, you know, you'll see some of these things on the blueprints. But you'll also, if you guys ever have kids, then you're going to need to know some of these terms that the kids are going to be using, okay, in school, hopefully, too. All right, so things I want to call to your attention, vocabulary. A line is a straight figure having no thickness that continues in both directions forever. Notice that the line has an arrow on both ends. The arrows indicate that it just continues on forever and ever. Okay? A segment, or a line segment is what it's called, is a portion of a line connecting two endpoints. So there's an endpoint here, and there's an endpoint here. It has a certain distance. It does not go on forever. It stops. Okay? Next term is ray. Is a portion of a line continuing in only one direction, starting at a vertex. Here's your vertex, okay? It is your starting point, and then it goes forever and ever. Okay? Parallel lines. All right, think train tracks. If you have train tracks that meet, that coincide, okay, you're going to have, that train's going to have some issues. Okay? They're parallel lines or two lines that will never intersect. There's always going to be the same distance from here to here as there is from here to here. Always going to be same distance apart. Perpendicular lines, they intersect to form right angles. And this little symbol right here, that little box, indicates that this is a 90-degree angle or a right angle. Okay? And this, of course, is not a line because it's curved. Angles. Again, this is all vocabulary here, guys. Angles is the amount of rotation between two intersecting lines or rays. So an angle is usually measured in between these two lines. All right. Whenever you see something on a test or I don't know where else you'd see it, and if it says angle ABC, that middle number or the middle letter is always going to be at your vertex. It's always going to be where the two lines are joined. So ABC means that B is going to be at your vertex where the two lines join. A right angle is an angle that measures exactly 90 degrees. Okay, so from here to here is 90. It's a right angle. It's perpendicular. If you ever do any building, and you're going to know that perpendicular or right angles give you the most strength of anything you build. Right now I'm down here in my workshop, my wood shop. This is a right angle, ladies and gentlemen. Okay, I use this to make sure that everything that I build is going to be as strong as possible. I've got a grandson that's going to be born in July, and I'm making him a bookcase right now. But I also realize that he will eventually be crawling and walking and pulling himself up on things. And if I don't have that right angle in there to make sure it's strong, it could collapse on him. So I want it to be as strong as possible. So I'm going to keep everything at a right angle. An acute angle, okay? An acute angle is less than 90 degrees, but more than 0. Okay? If you want an easy way to remember, acute little angle between 0 and less than 90. Obtuse angle is a fat angle. Measures between 90, more than 90, and less than 180. A straight angle, here's my B point right here. A straight angle goes all the way around 180 degrees. Okay, difference in spelling. I know this seems silly, but this is how I remember it. This is an angel. That's an angle. Okay, so it's spelled a little bit differently there. Triangles. Again, let's get this vocabulary out of the way so that we can just move on. Okay, an acute triangles means all of the angles, and when I say angles, where are we here? Okay, these angles are all less than 90 degrees. They're all less than right angles. That means it's an acute angle. It's a cute little angle. A right angle means one angle measures 90 degrees. Here's my symbol right here for it being a right angle. If you see the box, it means it's a right angle. Obtuse means one angle has to be more than 90. So this is more than 90. Could be 91 degrees. That's fine, okay? It's more than 90. Equilateral, all right? We're talking a little Latin here. Equi is equal. Lateral means side. So equilateral means all sides are equal. Isosceles, two of the sides are equal. Notice these little symbols right here, here, and here. Okay. If you see those symbols, that means they are equal in length. Over here for the equilateral one, all three sides are equal. And then for our last triangle, scaling means no sides are equal. Okay, this length is different from this length, which is different from this length. Scaling, no sides of them are equal. Okay, let's get into our quadrilateral. Quadrilateral is a four-sided closed geometric figure. Closed means that wherever you start, you're going to end at that same spot. Okay, this is four-sided, but it's not a closed figure. And it has to be a closed figure in order for it to be a quadrilateral. Remember, quad is four, lateral means side, so four sides. Parallelogram. Parallelogram is a quadrilateral, four-sided figure whose opposite sides are parallel. So this side over here is parallel to this side over here. This side over here is going to be parallel to this side over here. That means they are always going to be same distance. That means the distance here is always going to be the same as the distance here. That's one of the things that if you take the task test, they are going to assume that you know. Okay, a rectangle is a parallelogram with four right angles. Each one of these is a right angle. Okay, a square is a rectangle with all four sides equal in measure. So that means this side, this side, this side, this side are all the same length. And all of these angles are 90 degrees. Okay, so remember, a square is a rectangle. It meets this criteria, and it also meets parallelogram. Okay, a square has to be a rectangle, but a rectangle does not have to be a square. Well, hold on just one second. Ladies and gentlemen, I do want to call to your attention because this is going to be a part of algebra. Does anybody know, when we're talking triangles, what is the sum of the angles of a triangle? If you added up all of the angles inside this triangle, what would they add up to? Does anybody know? I'll give you a hint, 180. So if you add the angle here, 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 it's going to be 180. Any triangle, I don't care if it's acute, right, obtuse, scalene, isosceles, if you add up all of these interior angles, they're only going to add up to 180. It has to be. Okay? For a quadrilateral, if you add up these angles, it's going to be 360 degrees. Okay? Add up the inside of a quadrilateral, 360. Add up the interior angles for a triangle, it's 180. Okay, coming to a close here, ladies and gentlemen. Circles. All right, a circle is a plane figure in which every point on it is the same distance from the center. So this blue line is the same length as the green line, which is the same length as the red line. Okay, and these are called radius. Okay, the radius, or radii if you're talking plural, is the distance from the center point to the circle of the circle to the outside. And all radii of a circle are the same length. All right. Diameter is a line that connects one side of a circle to the other side of the circle and also passes through the center. Okay, so here's my center right here. And the diameter will go from one side through the center to the other side. It's always going to be the longest distance on any circle. Okay, because what happens is this from here to here is the radius. These are always going to be the same length, no matter where you put that. This is going to be the same length as this, which is also going to be the same length as this. All right, so the whole thing behind radius and diameter is always going to be twice as much as your radius. And your radius is going to be half as much as your diameter. Okay, on these, ladies and gentlemen, if you can match them up, see what you can do to do that. All right, same thing here for triangles. I'd like you to work on those for yourselves. If you have questions, please don't hesitate to send them to me. And circles, okay? Now the one thing about circles is you have to make sure, quadrilaterals and circles, some of these will fit in both or more than one category. For example, rectangle, okay, is D or A. A square is just A. Circle could be B. Diameter is C. Radius is E. And parallelogram could be D, because the opposite sides are parallel, or A, the opposite sides are parallel, or F. So any of those would be true. Okay, one other thing, let's get into some algebra, ladies and gentlemen. Complementary angles are two angles when combined form a 90-degree angle. So angle A here plus angle B here, when you add those together, they're 90. That means they are complementary. Supplementary angles are angles when you add them together are 180. Notice you have a straight angle here with another intersecting line here. If you add up this angle plus this angle, they have to add up to 180 degrees because a measurement for a straight angle is 180. So here's the problem. It says if two angles are supplementary and one of the angles is twice as big as the other, what are the measurement of the two angles? So if I say this side, I'm going to say that the side we don't know, I'm just going to call it X. And this is where we go into algebra a little bit, okay? So if this is X, this is twice as big, so that would be 2 times X. So I know that if 2X plus X has to be 180 degrees. All right, let's solve a little algebra. These are like terms, so 2X plus X is going to be 3X. Now I'm going to solve for X, so X is 60 degrees. Okay, if X is 60, that means this angle is 60, but this is twice what X is, so that means this angle is 120. So 120 plus 60 is 180, and that's what we're looking for. If two angles are complementary and one of the angles is 3 times as big as the other, what are the measurement of the angle? So I'm going to say that this is X, but this is 3 times as big. So I'm going to say this is 3X. All right, so 3X plus X is 90. Combine my like terms, 4X equals 90. So X is 22.5 degrees, okay? But 3X is 3 times as much, so 3X equals 67.5. Ladies and gentlemen, they will ask questions like this on the task test. So you have to be able to interpret it and solve it. And this is algebra. Okay, take a look at these. You're going to see these also on the task test. And again, these are just geometric symbols. If it says line AB, This is what it looks like, kind of in real life. But if you see a symbol for a line, notice it has AB, so it's going through points A and B, but it goes on forever. That's what that arrow means. If you have a line segment, it means you have a starting point and an ending point. Notice for the symbol, CD is the points that it goes through, but it stops. There's no arrows. Okay? Ray means it starts one spot and then goes on forever. E to F, these are the 2 points that are on that line, and here's your arrow that shows that it goes all in one direction. This is a symbol for parallel lines. All right, perpendicular lines, it may look like this, or it may look something like this if you're talking about it in a different way. Triangle GHI, that's pretty simple. Angle JKL, remember we've got J, K, L. The middle term is always the vertex. And then if they talk about circle O, what that means is the very center point is going to be called O, and the rest is going to be, that's just the general term for that circle. Okay, just so you can identify it. If they say, like, look at circle O and then compare that to circle P, okay, so you'll know what each one is referring to. Okay, ladies and gentlemen, can we finish that? I'm not going to try to get to biology today. If you get to the Google Classroom, there's going to be a science portion of it. Our first unit is going to be on body systems.
We don't have any of this.
You have not gotten these packets yet?
No, we don't. Anything that you read.
Yep. No, you haven't yet. But if you get to the Google Classroom, it's posted there, and I'll try to get one to you. But the other thing is, if you get there,
We don't have a paper written.
you don't have a paper for that. I agree. I'll try to get that to you, but just to tell you it is there, and I'll try to get a copy of it to you as soon as I can. But if you notice on, all right, in the Google Classroom, you're going to see in science, you're going to see a sheet that corresponds with what the packet is. Ladies and gentlemen, what I'm going to be doing is I'm going to be using a lot of videos to explain the science portion, because I cannot take you on an exploration inside of a body. There's just no way that I can. So what I did is I took some videos and I linked to those off this sheet. And all you have to do, click on that, and you will see the video for it. Okay, it'll be on, this is on the circulatory system, actually. This is on body systems, and it will give you all of the different information that I want you to have on that. Okay, I'm not going to go through that right now. Let's get back here. All right, so ladies and gentlemen, if there's any other questions, I'd be more than happy to answer them. Otherwise, I'm going to let you go now.
Where's Sam?
I think she had a meeting this afternoon. So if you text her, or she probably will be able to get back to you on that. Okay?
What we're supposed to do, just exit off and go on about our day?
Then this is, let me see here. Your schedule.
Hold on, I got the schedule for you guys. So if you want more information, or if you want more time with Mr. Jim, his office hours are today after lunch. Other than that, have a happy Friday.
And have a happy Memorial Day weekend.
You have fun too. Have fun.